All right, today your objective is the students will learn to evaluate exponential functions in order to make predictions about real-life scenarios. Remember, evaluate is just another word for substitution. Remember, an exponential function is in this form, f of x equals a times b to the x power. Your a is your y-intercept. And remember, your b determines growth or decay. So again, you're going to evaluate the exponential functions in order to make a prediction about real-life scenarios. And since we are in real life, we need to remember labels. All right, here we go. So this is just, the front page of this is just simple evaluating. All you're going to do is using your calculator, wherever you see an x, you're going to put a -2. So your work would look like this. So h of -2, 8 times 2 to the -2nd power. And then I'm going to plug this into my calculator, and I will show you how I do that. While that's loading, you should determine if this is growth or decay. It is growth because 2 is greater than 1. So here's how I would plug this in on my calculator. As soon as it loads. In the meantime, we'll also write our answer like h of -2 equals. Okay. All right, clear that. 8 times -2. I'm sorry, 8 times 2. Let me clear that. 8 times 2 to the -2 power. And we get 2. And that would be your answer. So you just evaluated this function, h of x, at -2. Skipping down to one like number 3, it's definitely decay because 1/2 is between 0 and 1. So you don't have to write y, but you just need to make sure you understand y. And then, again, you're just going to evaluate this equation. Now be careful with your fractions. I'll show the math and then I'll show what I key in on my calculator. I always use parentheses just to be safe. So 7/4 times 1/2 to the 2nd power equals. And then I'm going to key it in on my calculator. 7 divided by 4 times 1 divided by 2. You could also use 0.5 for 1/2. Close, caret to the 2nd power. So I got 0.4375. You could leave your answer like this, or you could hit math, enter, enter, and it will simplify the fraction for you. Either one will work. Typically, if it's a nice decimal and it doesn't have too many numbers, you can leave it as a decimal, but if it is a long one, I will have you put it into a fraction. So we'll see an example of a longer one in number 5. Again, yes, this is a fraction, but 5 divided by 3 is actually just 1.666 repeating, which is greater than 1, so it's growing. Okay, and that's because 5/3 is greater than 1. So I'm just going to evaluate this function at y equals -3. So 4/7 times 5/3 to the -3rd equals. Use your calculator. 4 divided by 7 times 5 divided by third, 5 divided by 3 to the negative third power. Enter. So see how this is a much longer decimal? Instead of rounding this, which you could, I would just round it maybe to 0.01234. You could hit math, enter, enter, and it will put it back as a fraction. So I would accept 0.1234. However you round, just make sure you round correctly. And or I would accept 108 over 875. And then circle your answer. Okay? So I think with those 3 examples, you should be able to complete 1 through 12 and then move on to the real life scenarios. All right, so we just evaluated exponential equations, and now we're going to use these in real life to make a prediction. So your problem is Marissa invests $300 at a bank that offers $5,000 compounded annually. The function f of x equals 300 times 1.05 to the x projects the growth of her investment, f of x, in dollars, x years after 2000. So the key here is they give you your equation, and they give you what x means, but x is years after 2000. So what value will you substitute for x if you're interested in the amount in the year 2010? Now, if you're good with your math, which most of you are, you can realize that 2010 is 10 years after 2000, or you could do 2010 minus 2000 to get 10. So we're going to be using x equals 10 because 2010 is 10 years after 2000. And again, I'm trying to give you as much explanation as possible. All right, so according to the model, what will the concentration of f of x in the year 2010 round to the nearest hundredth? So we're going to round to the nearest hundredth because we should be getting a money answer. So you might want to make that note. Okay, so f of x, which is just f of 10 now, is 300, which is your y-intercept, 1.05, which means it's growing, to the 10th power. So this is just what you did on the front. So use your calculator, 300 times 1.05 to the 10th power. Enter. 488.67. So that's $488.67, which makes sense because it's growing and she started at 300, so it should be a bigger answer. What will the concentration be in 10 years? So in 10 years, we're going to be in the year 2026. Unfortunately, Miss Bailey is going to be 36 years old then. So 2026 is 26 years away from 2000. So you're actually using x equals 26. Because 2026, again, is 26 years after 2000. So evaluating f of 26 equals 300 times 1.05 to the 26th power. All right, whoops. So 300 times 1.05 to the 26th power. So in 26 years, she will have $1,066.70. Okay. All right, and then we're just going to graph, but it's really just going to be a sketch. So there's going to be some key things that I'm going to look for. So you're going to have to find the values using the table for 0, which we already know since the y-intercept is 300. Okay, and then I want you to find when x is 10, x is 15, x is 20. So your graph is already labeled for you, but I'll go in and explain. This is just your title. It's representing the money invested, or we could even say money earned. So how much she gets for her investment. Your y-intercepts, your y's are going to just be in money, and your x's are going to be in years after 2000. Okay, so then we have our 0, 10, 15, and 20. Again, this is just a sketch, and based off of our equation, f of x equals 300 times 1.05 to the x power, you know your y-intercept is 300. So I would be looking for where you place your y-intercept, and you know you're growing. So I will be looking to make sure that you start with your y-intercept. You can just put it right around here and make it known that it's 300, and then just sketch that it's going up. And then what you can do is you could just evaluate these if you wanted to use the table. You could go into your y equals. You could key in 300, 1.05 to the x. Okay. You could hit the second table, and then here's your value. So you can see at 0 it was 300, at 10 it was 488.67 cents, which we already calculated. And then to get 15, you can just use the arrows to scroll down, and you go to 15. So you can see when x is 15, so that would be in the year 2015, she has earned about $623.68. So you could just put that here, $623.88. And then 20 years from now, she will have $795.99. So this is how a real-life example works. Notice we have labels, we have rounded correctly, and we're in money and years. So there's a good example for you to go off of. Another example would be when Matt buys a new car at the cost of $25,000. The car depreciates approximately 15% of its value each year. The exponential function f of x equals 25,000, so the car started at 25,000 and it's depreciating, so it's going down. So that is your equation. It's x years after 2000. So again, your question is, what value will you substitute for x if you're interested in the amount in the year 2010? Well, 2010 is 10 years after 2000. So we just use x equals 10. So here's your model. Your model is f of x equals $25,000, which is how much the car initially starts at, 0.85x. So now if I want to find f of 10, all I do is substitute 10 in for x. So you'll see how I'm going to color code this if you want to color code. Oops. F of 10 equals 25,000 times 0.85 to the 10th. And again, we're rounding to the nearest hundredth because we're in money. So I'm going to come over to my calculator. 25,000. And you would expect that the number is going to go down because you're depreciating. Oops, not 0, 10. So after 10 years, your car is only worth $4,921.86, which makes sense because you're putting miles on it. You might have gotten into an accident, which means it's a damaged car. Lots of different things that make your car depreciate. Okay? And now we want to know, what will the car be in 10 years? So in 10 years, we're in 2026, which means we're 26 years after 2000. Miss Bailey is 36 now. So F of 26, and again, you might not need to write all of this out anymore, equals 25,000 times 0.85 to the 26th power. Let's see how much that car is worth. Okay. 0.85 to the 26th power. Oh, it's only worth $365.45. So something must have happened to that car. Remember, this is how we write money. $365.45. Hey, it's still worth something. Okay? So then you're going to come down here. You're going to graph again. I have labeled this as car cost or car value, you might want to say. Either one would be correct. Your X again is years after 2000. Typically the time is in X. Just double check. I think your paper might say 2010 right there, but it is 2000. And then money. We're evaluating at 0, 10, 15, and 20. So you want to put those in. 0, 10, 15, and 20. Our function is f of x equals 25,000 times 0.83 to the x. So what that means is our y-intercept is 25,000. That's where you start. And then since 0.83 is less than 0, it's decaying. So you could start further up. So I'll be looking to make sure you graph your y-intercept correctly and then just show that it's a decay. And if you did your y equals on your graph to get your table, you have to clear out this one and put 25,000.83 to the x power. And then you hit second table or second graph, and you can see all your values. So we know when x is 0, you're just at your y-intercept, you're starting at 25,000. In 10 years, the car is worth, we already calculated, but let's just make sure, $3,879. Did I key this in right? No, that's not correct. Let me check my 25,000. Oh dear, look at that. I put 8.3, and I think I've been saying 8.3. Holy crap. It is 0.85. Yes, even I, folks, make mistakes. I am not perfect. All right, so now second table. There we go. So you notice it's a little more off. That's just because the computer on the calculator on the computer has rounded. So you can put either number, I won't mark off, as long as you have one or the other. So I'll know which both numbers are. And then the 15 is 2183. So again, the calculator just rounds a little differently. So $2,183.90 and then $968.88. Oh, I'm sorry, it's 99 cents. My B. Okay? So again, now here's an example of exponential decay. So you can see the trend over time. The car value is going down. So what you need to do is finish page 3 and 4 of this packet. I think actually this is page 3, so you just need to finish page 4. Be careful in a couple of them, because in question number 3, it's giving you years after 2003. So not years after 2000, but years after 2003. So you have to take away 2003 to get whatever X is. And then also remember that we are in the year 2016. So again, now you would take away 2003. Also keep in mind that your answers are going to be populations. So it's people, but I also think it's in millions. So you can see that, oh, just kidding, no it's not. It is just people. So we got the 35,000 and your labels are in people. Okay? And number 4, it's parts per million. So you'll have a different label, but this time it's years after 2010, so back to normal, and your label will be parts, not there, parts per million. Okay? So hopefully you found this video helpful and you can refer back to it when you study for your test and your quiz. So again, you're going to finish this packet. You turn it into me, or if you have Miss Young, you turn it into me or Miss Young. Complete your worksheet and then complete your closure.